Greetings once again, this is Dr. T, and I'm here today with a little lesson on finding the greatest common factor. And what we're going to do today, with the help of this wonderful PowerPoint from Henry County Public Schools in Virginia, is we're going to learn how to find the prime factorization of a number. We're also going to learn how to find the greatest common factor for a set of monomials. And I think you're going to find this helpful, and hopefully this will clarify what it is you're supposed to be doing on your assignments in class. So a prime number, this is when we talk about doing the prime factorization, what we're trying to do is find the prime numbers that go in a number. So the prime number is a number that can only be divided by 1 in itself. And so things like 1, 2, 3, 5, 7, 11, 13. You can count out numbers that are only divisible by 1 in themselves. And a composite number is any number greater than 1 that can be divided, that's not prime. So it can be divided by things like 2, 3, 5. So you need to tell me now, is this a prime or a composite number? 37. Go ahead and try to figure that out on your own. Pause the video and I'll give you the answer as soon as you hit play. This one is prime, right? It's not an even number, and when you add the digits together in the number, they're not divisible by 3, and it's not divisible by 5. How about 51? Try that one out, and when you hit play, I'll give you the answer. Okay, 51 is a composite number. It's divisible by 3. Anytime you can add the digits together in a number, like here we can add 5 plus 1 equals 6. 6 is divisible by 3. So anytime we can add these numbers together and divide that sum by 3, then the original number is divisible by 3. Okay, is 89 prime or composite? I'll give you a second to work on that. When you hit play, I'll show you the answer. Hopefully you recognized that 89 is a prime number. It's not divisible by 2, 3, 5, or any other number. Alright, so now we've got to find the prime factorization of 84. The first thing you're going to do is just try to divide it by something. I start with 2's, here we start with 4, because it's pretty obvious that 84 divided by 4 is 21. But we can break those numbers down. 4 can be broken down into 2 times 2, and 21 can be broken down into 3 times 7. And what that's left us with is 4 prime numbers. Right? And now, we can treat this as 2 squared times 3 times 7, and that's the prime factorization. Alright, try the one for negative 210, and when you hit play, we'll go over the answer. Okay, for negative 210, obviously it's divisible by 2, it's divisible by 5, and it's divisible by 3. So starting out, we know that we can take the negative 1 out, and then that leaves us with a positive number. That's 7 times 30. We could see the 7 times 3 is 21, so 7 times 30 is 210. And then we can break down the 30 into 6 times 5. And my next question would be, can we break anything else down in this string of numbers? Hopefully you recognize that the 6 can be broken down into 2 times 3. So the ultimate prime factorization of negative 210 is negative 1 times 2 times 3 times 5 times 7. And the product of those numbers would be negative 210. Alright, so now find the prime factorization of 45a squared b cubed. And we do the same thing. We're going to work with the number first. We're going to try to break it down into its prime components. And then we're going to break down the variables. So if we break down 45, now we all know that 5 times 9 is 45. Then we have our a times a. That's the same thing as a squared. B times b is b cubed. And we can, I would now ask you, is there anything else that can be broken down further? And of course you recognize that the 9 could be 3 times 3. 3 times 3 times 5 times A times A times B times B times B. This is what you have here. We can express the 3 times 3 as 3 squared, but we want to leave the variables in their pure form without using exponents. Now, what is the prime factorization of 48? Well, 48 is an even number, so we know it's divisible by 2. We also can add the 4 and the 8 together and get 12, which is divisible by 3, which means 48 is divisible by 3. Those are the only clues I'm going to give you. When you hit play, you'll get the answer. Hopefully you picked answer 4. You see the 2 times 2 times 2 times 3. And they broke this down into steps. 3 times 16 is what I said when it's divisible by 3. The 16 is 4 by 4. But then, of course, we can break each of those 4s down into 2 times 2. Okay, so what is the greatest common factor? We've looked at factoring, a prime factorization of a number. What is the greatest common factor of 2 or more numbers? Well, that's going to be the largest number that can divide into all of the numbers. So we're going to be looking at the largest number that can divide into all of those numbers. So find the greatest common factor of 42 and 60. Well, the first thing you have to do is get the prime factorization of each of these numbers. And 42 we can start out with as 2 times 21 and then 21, so you're going to do that. And so 42 can be written as 21 times 2, and then 21 can be written as 3 times 7. Hello. Right? And then we have 60, which of course is divisible by 5, 3, and 2. So if we do this, we've got to have 2 times 2, which is 4, times 3, which is 12, times 5, which is 60. Now, what do these things have in common? This is where we're looking for the greatest common factor. Because once we find the numbers that are in common, we can multiply them and find the greatest common factor. Okay, so the 2 and the 2 are the same, and the 3's are the same. So the greatest common factor is going to be 2 times 3, which is 6. 6 is the largest number that can go into 42 and 60. All right, find the GCF of 40a squared b and 48ab to the 4th. Again, we're going to carry out the same process. We're going to find that 40a squared b is 2 times 2 times 2 times 5 times a times b. Because we had a squared b, a squared is a times a, and then there's your b. Got it. Okay. Now the 48ab to the 4th is going to be broken down into 2 times 2 times 2 times 2 times 3, and then we have the 1a and we have 4 b's. And now what we're going to do is find the terms that are in common and multiply them to find the greatest common factor. So what are their common points? The 2's, we've got 3 2's that are common. We have an a common and a b common, so the greatest common factor is, when we multiply these through, we're going to find that it's 8 AB. Because remember, 2 cubed is 8, or 2 times 2 times 2 is 8. Alright, what is the greatest common factor of 48 and 64? I'll give you a chance to try this, and when you hit play, I will give you the answer. Hopefully you picked 16. If you didn't, you know what you need to do. And I hope this has been helpful, and I look forward to seeing you in the classroom.